page 516. And what we're going to do to each of these questions is we're going to add the words and graph. So we're not going to just find the amplitude. We're going to practice taking our original functions and graphing them with our transformations unit. So now we have, basically we have 3 new parent graphs, our sine, cos, and tan graph. And we can go back to our first unit and do all the transformations with our new graphs. Now, we're also going to find that with our sine and our cos graph, we can actually develop a shortcut for graphing them so that we can graph them even faster. Because you know, like y equals mx plus b? You know the slope and the y-intercept? That's sort of your shortcut for graphing lines. You don't use transformations. So sometimes we have shortcuts that allow us to graph them even quicker. You could use your transformations. So for example, in y equals sine of 2/3 x, or 2/3 sine x, that number's in front. Would it be vertical or horizontal? It would be vertical, so we'd have a vertical compression. So in A, we'd have a vertical compression. You're going to multiply y by 2/3. Yes? We're going to do them a little bit later. So we got a vertical compression, y by 2/3. Now, when you go to graph a sine graph, it has some important characteristics. It has maximums, it has minimums, it has a center line. It had, remember we labeled our axes family on here. Your axes family, when it's labeled, are x values. Can you see that you're just multiplying y by something? Your x values wouldn't change. So we can still label our axes family. You have a center line on your original graph at y equals 0. What happens to your center line when you multiply it by 2/3? Nothing. It's still going to be there. And your sine graph had a maximum at 1 and a minimum at -1. But when you multiply that by 2/3, can you see that your maximum is now 2/3 and your minimum now -2/3? Now you're going to hear me talking about where does a sine graph start? Okay? So if we go back to our pictures that we drew earlier, our sine graph started at 0 going up. But even more specifically, we're going to talk about it starting on the center line going up. So our sine graph starts on our center line going up. Our cos graph starts at a maximum. So those are going to be key words that I'm going to use over and over again to help develop our shortcut. Okay? So our sine graph starts on the center line going up, which happens to be 0 in that example, and in our example, it's also 0. So if we started in the center line going up, there's our center line. At our first axis family, it's at the maximum. Next axis family, back to the center line, down to the minimum, back to the center line. Draw your graph. Add arrowheads to show that it goes on forever. And there we have our graph. Now that we have our graph, we can say what the amplitude is. That's the distance from the center line to a maximum, or from the center line to a minimum. It's 2/3. What did we have in our equation? A 2/3. Maybe that's a shortcut. Maybe we can figure out our amplitude is the same as that number in front. So we're going to check with the second example. We have -4 cos x. Okay? So in B, that would be a vertical reflection and a vertical stretch. You would multiply your y values by a -4. So when we go to graph, our x values, we can put our axis family on here. They're not going to change. Our center line, when you multiply by -4, it's not going to change. But our maximum, which is at 1, when you multiply that by -4, it's going to become -4. And your minimum that was -1, when you multiply that by -4, it's going to become +4. Now, a cos graph normally starts at a maximum. But if we have a vertical reflection, it's going to start at a minimum. So when I go to graph this as part of the shortcut, I know it's starting at a minimum. The next axis family is at the center line. Next axis family is at a maximum. Back to the center line, back to the minimum. Every time you draw your sine graph, it has to have this nice curve to it. If you draw it with straight lines, you will lose a half a mark because it's not the right shape. So what is our amplitude? Our amplitude is, distance from the center line to the top is 4. So in this one, even though the number in front was a -4, your amplitude is a distance. It's always a positive number. The negative in front just meant for your cos graph, it started at a minimum instead of starting at a maximum. If you had a negative in a sine graph, it would still start in the center, but instead of going up, that flip would cause it to go down. Okay, questions for practice. 3, A and B, 4, 5, and 9.